Welcome to Dividing Polynomials, Part 1. Okay, before we get started, I'm going to just refresh your memory about the process of long division that you learned many years ago. So to do that, let's say we had something like we were going to divide 7 into 38. So just to refresh your memory, you would have said, well, 7 goes into 38, let's see, I think I can do it 5 times. And then you'd have gone 5 times 7, which is 35, and then subtracted to find the difference. Said, yeah, 38 minus 35, that's 3. And, oh, well, 7 doesn't go into 3, so I'm just going to say that's my remainder. So remainder 3. And so that would have been my long division done. And then we would have had a corresponding division statement, which maybe you guys didn't call the division statement back then. But let me just show you what that is. So the division statement would have looked this way. You'd have said 38 is equal to, dividing by 7, and times that. So my quotient here is 5 for my answer. And then I would have added my remainder to it. And so this was a way you checked your work. And we call that the division statement. What I'm now going to do is I'm going to do this with polynomials. Okay? So I'm going to take something like, and here's my first example, x minus 2. Okay, and we're going to divide that into x squared plus 5x minus 1. And kind of show you how similar it is in the process that we used up here. To start off with, what we do is we focus in on the first term here. We're dividing by the binomial x minus 2. So our focus is the x. Okay? And you notice that I've written this in descending order, and that means that the highest power of x is written first, and then the constant or the number is at the end. And same thing here with my dividend. I'm going to write it in descending order, so I got x squared, then the x term, and then the constant. It just makes things a little bit easier if you have it in order. So here's what we do. We just ask ourselves, x times what gives us x squared? And just like up here, we went 7 times what would give us 38. So here, x times, x. Okay, so, and then I have to take x and multiply these two things by that x. I'm going to go x times x is x squared, and x times minus 2 is minus 2x. Now that's not really any different than what we did up here. We went 5 times 7 is 35. And then what did we do up here? We subtracted. So here, we're going to put brackets and subtract. Okay, so it's really the same process. Now x squared minus x squared is gone. Then I have 5x, and here's a double negative, so it's actually like plus 2x, so that makes 7x. Then I'm going to carry down the next term, which is minus 1. And now I'm going to continue. I'm going to look at this x and ask myself, x times what gives me 7x? And I go, oh, that has to be positive 7. Okay, now let's multiply it. 7 times x is 7x. And 7 times negative 2 is minus 14. Then we're going to put brackets and subtract, just like we would normally do in any sort of long division. So now I have 7x minus 7x, so that cancels. Then I have a minus 1, and I have a double negative here, so that's like saying plus 14. So negative 1 plus 14 is 13. Well, I look at it now and I go, I guess that's the end of the line. I can't divide rather x into 13. So that's going to be my remainder. So my remainder is 13. And to just totally do the same thing that we did up here, I'm now going to write that using the division statement. Okay, so it would look like this. My x squared plus 5x minus 1 is the equivalent of, and I'm dividing by x minus 2, so I'm going to write that with brackets, x minus 2. And then I multiply that by my answer. Okay, just like here, we divided by 7 and we multiplied by the quotient 5. Well, here I divided by x minus 2, and now I'm going to multiply that by the quotient x plus 7. And then I have to, just like up here, add the remainder. So I'm going to go plus 13. And that's the division statement, and that's that example completed. Okay, so I'm going to do another one now, a little bit more complicated, and see how that goes. Okay, so I'm going to clear off the screen. So here we go. We're going to take something that looks like this. 5x cubed and plus 10x. And we're going to divide that by x plus 4. Now you notice that I wrote it this time as a fraction. So you could certainly do that. It actually means exactly the same thing as if I was to write it this way. And of course we're using long division here, so I would rewrite it this way. Alright, so there it is. I got my x plus 4, and I'm dividing that into 5x cubed. Now notice there's no x squared term. It's easiest if you just do this. Fill it in with a 0x squared. It makes it easier if you don't leave out any spaces. Then comes the x term. And then as far as constants go, well, there really isn't any, but I'm going to write in plus 0. So it's kind of like I filled in all the blanks. Now I'm going to focus on the x, and I'm going to ask myself, x times what gives me 5x cubed? Well, that would be times 5x squared. Okay, so I'm going to now multiply the x plus 4 by 5x squared and write those terms underneath. So 5x squared times x is 5x cubed, and 5x squared times 4 is 20x squared. Brackets, and I'm subtracting. Okay, so 5x cubed minus 5x cubed is gone. 0x squared minus 20x squared, so leaves me with minus 20x squared. And I'll bring down the next term, which is plus 10x. Okay, now I look at the x, and I ask myself, what do I multiply it by to get negative 20x squared? So I need negative 20x. Now I'm going to multiply negative 20x times x. So I get negative 20x squared, and negative 20x times 4 is negative 80x. Okay, and I'm going to put brackets because I want to subtract them both. Okay, negative 20x squared plus 20x squared cancels, and then we have 10x, and this is like plus 80x, so that's 90x's. And I'm going to bring down that next term, which happens to be 0. So now I got to look at the x and say x times what makes 90x? Well, that would be plus 90. Okay. So now I go 90 times x, that's 90x's. And I have 90 times 4, which is positive 360. Brackets and subtract. And let's see what we have now. So 90x minus 90x is gone. And 0 and negative 360 is negative 360. Well, guess what? That's my remainder. So I'm just going to put that up here. Remainder of negative 360. And I think I will just stop there. I don't want to drag this on any longer. And that is our look at dividing polynomials.